Let's work on some mole problems. So let's say that you have a gold ring that has a mass of 10.94 grams. And we want to convert that to moles. Well, the first thing we have to know is how many grams there are per mole for gold. So we look up the atomic mass off the periodic table. And that tells us that 1 mole for gold is 197.0 grams. So now we can do a factor labeling problem which will help us to convert from grams to moles. We have 10.94 grams of gold. We want to cancel out grams of gold, so we'll put that in the denominator. That way it cancels out. And we're going to convert to moles of gold, so we'll put that in the numerator. And the periodic table tells us that 1 mole of gold equals 197.0 grams. So we're going to take 10.94 divided by 197.0. And since we've got 4 significant digits here, we're going to round our answer to 4 significant digits. And we're going to get 0.05553 moles of gold. So now, let's say we want to find out how many atoms this is. Well, we can start with the 10.94 grams, or we can start with the 0.05553 moles, since they're equal. So we'll start with the 0.05553 moles of gold. We're going to want to cancel out moles this time, so we'll put it in the denominator. And we want to convert to atoms of gold, so we'll put that in the numerator. Our moles of gold will cancel out, and we know that 1 mole of any substance equals 6.02 times 10 to the 23rd particles, and an atom is a type of particle. So we're going to take 0.05553 moles, multiply it by 6.02 times 10 to the 23rd, and again, we're going to want to have 4 significant digits in our answer. So we're going to get 3.343 times 10 to the 22nd atoms of gold. Alright, so let's say that we have a sample and it contains 5.00 times 10 to the 20 particles of iron. And since iron is an element, we're talking about atoms. So we have to know that we want to find out what fraction of a mole this is. So we have to know that 1 mole equals 6.02 times 10 to the 23rd to solve this problem. So we're going to have 5.00 times 10 to the 20. I'm going to shorthand particle by just putting P-A-R-T of iron, and our symbol for iron is Fe. We want to cancel out particles, so we'll put that in the denominator. And we want to go to moles, so we'll put that in the numerator. And 1 mole equals 6.02 times 10 to the 23rd particles. So we're going to take 5.00 times 10 to the 20, divide it by 6.02 times 10 to the 23rd. Since our number that we were given has 2 digits, we're going to want 2 digits in our answer. So we're going to get 8.31 times 10 to the negative 4 moles of iron. Now we want to find out what the mass of the sample would be, and we could start with 5.00 times 10 to the 20 particles, or 8.31 times 10 to the negative 4 moles. Either way, we're going to get the same answer. So I'm going to start with 8.31 times 10 to the negative 4 moles of iron. I'm going to cancel out moles of iron by putting it in the denominator. And I want to go to grams of iron, so we'll put that in the numerator. So we'll have to look up iron on the periodic table, and that will tell us how many grams there are per mole. And we see that for iron, 55.85 grams equals 1 mole. So 8.31 times 10 to the negative 4 times 55.85 will give us 4.64 times 10 to the negative 2 grams. Now let's talk about molar masses. Molar masses are the mass in grams of 1 mole for a compound. The term also used is molecular weight. So you might see molar mass, you might see molecular weight, and you might even see what's called a formula weight. And basically what we're looking at is the grams per mole for a particular compound. To calculate the molar mass of the compound, we have to know how many types of atoms there are in the compound, how many of each type of atom there are, and then we're going to multiply them by the atomic masses on the periodic table, and the sum will be our molar mass. So let's look at an example. Let's say we want to calculate the molar mass for acetic acid. Well, the first thing we have to know is the formula for acetic acid, so we can figure out what types of atoms are present and how many of each type there is. So think back to how we name compounds. We know that acids have hydrogen as their positive ion in it. Since there's no hydro as a prefix over here, we're looking at an acid that contains oxygen. Ic goes to 8, so our negative ion is acetate. Acetate is C2H3O2. So if we want the formula for acetic acid, we would have HC2H3O2. Hydrogen is a +1 charge, acetate's a -1 charge. So now we have our formula. We'll be able to calculate our formula weight. So we have hydrogen, carbon, and oxygen in our compound. There's 1 + 3, 4 hydrogens, and we'll multiply that by the atomic mass. So that'll give us 4.04. We've got 2 carbons, so we'll multiply that by 12.01, and that'll give us 12.01. And we've got 2 oxygens, and we'll multiply that by 16.00. That'll give us 32.00. To find the molar mass, then, we're going to add these numbers together. So we'll get 60.06 grams for every 1 mole for acetic acid. And just like every atom has a particular atomic mass, how many grams there are per mole, every compound will have its own molar mass because the type and number of atoms that are present vary. So now let's do a factor labeling problem with acetic acid. Let's say that you're given 89.72 grams of acetic acid. And we want to find out how many molecules there are. All right, well, we have grams and we want molecules. So we're going to have to do a factor labeling problem. We've got 89.72 grams of HC2H3O2. We want to cancel out grams, so we found out that 60.06 grams equals 1 mole for acetic acid. That'll cancel out grams of acetic acid. And now we'll do a second step 1 mole of acetic acid will equal the number of molecules. And we know that that is 6.02 times 10 to the 23rd. So we'll take 89.72 times 6.02 times 10 to the 23rd divided by 60.06. We've got 4 digits in our number, so we're going to round our answer to 4 digits. So we'll get 8.993 times 10 to the 23rd molecules of HC2H3O2. So let's say the next question says, how many carbon atoms do we have? Well, if we look at our formula for acetic acid, for every 1 acetic acid, there are 2 carbons. So if we have 8.993 times 10 to the 23rd molecules of HC2H3O2, for every 1 molecule, there will be 2 atoms of carbon. So that's going to give us, we'll just pretend this isn't here, 1.799 times 10 to the 24 atoms of carbon.